Well, this video is for Math 95, and this is for the sample midterm. So let's go ahead and get started. The last page, I will say the last page on the midterm has rules of exponents formulas on it for you. I'll talk more about that when we get to those problems. All right, so problem number one, we start out with the inequality problems. So we've got 1 plus 7 times 3 minus 5x less than 15. A couple things going on in this problem. Number one, know your order of operations. Don't fall for this. You can't add these together. This 7 has to get distributed into the parentheses. 1 plus 21 minus 35x less than 15. So that's 22. Minus 35x less than 15. Right here you've got a couple choices. You can subtract the 22, right? This minus sign is attached to the 35x, so don't lose that. This is a positive 22, and so you've got to subtract it if you want to cancel it out. That'll leave us with negative 35x over here, and looks like negative 7 here. Divide on both sides by negative 35, and we get x greater than 1/5. If you like calculators and decimals, you'll get 0.2 if you do negative 7 divided by negative 35. That's fine too. And so this is x greater than 0.2. And then if we want to put this on a number line, here's 0. We can put 0.2 right there. And there's x greater than 0.2. The other thing you can do is at this point right here, 22 minus 35x less than 15. So you can subtract 15 on both sides and add 35x. And that saves you the trouble of having to remember to flip that sign around. X greater than 0.2. You still get the same answer. It's just, I usually do it that way just because I don't like to mess with the negative coefficients there, but there's nothing wrong with it. I'm not even sure really why I do that. But okay, that's problem one. Let's see what else we've got here. Problem two is a compound inequality. One important thing to remember about these compound inequalities is instead of there being two places where you have to add or subtract or multiply or divide, right? There's three places, right? There's three different places. So if I want to add 3 here to cancel that out, I've got to add 3 here and add 3 over there. So this cancels out. Negative 2x greater than 4 less than or equal to 15. And then same thing with the negative 2. I'm going to divide everything through by negative 2. That makes these flip around. We're left with x in the middle. This will be negative 2, and over here we'll get negative 7.5. Okay, so there's our answer. X less than negative 2, but greater than or equal to negative 7.5. There's 0, negative 2, negative 7.5, and then we want everything in between. Okay, all right, so that's problem 2. Let's see here. Problem 3 is an OR problem, so let's see what we got. 5x plus 7 greater than 2x plus 1, or negative 2 times x plus 6 greater than 8. All right. So let's see here. Well, let's go ahead and solve this one. So those cancel out. 3x plus 7 greater than 1. Subtract the 7. 3x greater than negative 6. So x greater than negative 2. All right, let's solve this one. Negative 2x minus 12 greater than 8. Add the 12. Negative 2x greater than 20. Divide on both sides by negative 2. That's going to flip this around, and you'll get x less than negative 10. So there's our answer. X greater than negative 2 or x less than negative 10. There's our 0. There's negative 2 and negative 10. So x less than negative 10 is here. X greater than negative 2 is going to look like that. And you can see this is typical of the OR problems. They go off in opposite directions. All right, let's keep going here. I think problem 4, we get into the absolute value questions. 4 is an absolute value equation, and then 5 will be the absolute value inequality. Okay, so problem 4, we've got absolute value 4x minus 5 equals 15. Now the fundamental idea of an absolute value is that it splits into two pieces because you've got two possibilities. 4x minus 5 could be 15, or 4x minus 5 could be negative 15, because when you take the absolute value of that negative 15, you'll still get 15. Okay, well now that that's done, we just need to solve these two equations. 4x equals 20, x equals 5. Great. Over here, 4x is negative 10, and so x is negative 2.5. Okay, so that's problem 4. Now, problem 5. This is one of these absolute value inequalities. So, what we want to do is isolate that inequality. First thing, don't try to distribute that 2. That usually does not work. Okay? It works sometimes and not others, and so I encourage you not to do that. So let's just get the absolute value by itself. Divide on both sides by 2. Let's see, greater than or equal to 12. There we go. Now we've got the absolute value by itself. Now we can split it into two pieces. 3 minus 2x greater than or equal to 12. 3 minus 2x. And remember, when we make this negative, it's like we're multiplying by negative 1. That's going to flip that around. Okay? All right, so let's go ahead and solve this one. Negative 2x greater than or equal to 9. Divide on both sides by negative 2. X less than or equal to negative 4.5. Okay, let's do the same thing here. Negative 15, divide by negative 2, x greater than or equal to positive 7.5. Okay, so now if you look at this, right, if you went to just graph these, you can see these are going off in opposite directions. This is an OR statement. Alright? I don't know if you need to do this or if you want to do this, but something you can put on your note card if you want to is to remind yourself that if you've got an absolute value greater than something, then this will be OR. Okay? And if you've got an absolute value less than something, it will be and look like that. Okay? So, I don't know if that's helpful to you or not, but that's something that you can do to remember how these absolute value inequalities work. It's also a good reminder that to split this in two pieces But whatever works for you is fine. So let's see here. That's problem 5. Oh, and now I think we're going to get into the factoring problems. Well, let's take a look at those. Problem 6 is pretty straightforward. Trinomial factoring. X squared plus 11x minus 42. So, if you know your times tables, you know that 7 times 6 is 42, but 7 and 6 don't have a difference of 11. So let's look at some more factors of 42. 2 times 21, 3, does 3 go into 42? Yeah, it goes 14 times. 4 does not go in, 5 does not go in, 6 times 7, that's it. Okay? And then here's the one right here that has a difference of 11. So we would set this up as x plus 14 times x minus 3. And that's it. That's why I said it was straightforward. Problem 7. Problem 7 is the factoring by grouping problem. And so you can recognize these because they have 4 pieces, right? The trinomials are called trinomials because they have 3 pieces. These have 4 pieces, right? And the trick here is split it down the middle, pull out the x squared in the front, and whatever is a common factor back here. Now with this minus sign, it's a little bit tricky, okay? So your common factor then is going to be minus 3, and you'll be left with x plus 5. Notice how this changes from negative to positive here because we factored out a negative. So when you multiply back through, there's your negative 3x, there's your minus 15. Okay, now that we've done that correctly, these are both the same, so they're a common factor. We can factor it out, and we'll be left with x squared minus 3, and that's it for problem 7. Okay. Problem 8. Less straightforward, but still not too bad. Let's see here. 3x squared plus 16x plus 20. Okay. So let's see. The 3 is prime. There's only one possibility there. 3x times 1x. The 20 can be 1 times 20, 2 times 10, or 4 times 5. So let's see, I'll try the 4 and the 5 first. If I put 4 here and 5 here, that's 12 and 5 is 17. What if I switch them up? 4 and 5, 15 and 4 is 19. No good. The 2 and the 10, let's see, I put the 2 here and the 10 here, then 10 and 6, yeah, makes 16, plus and plus, and there we go. Now the last one is one of these multi-step problems where we need to pull out a common factor first and then factor what's left inside the parentheses afterwards. So, let's see, these coefficients, these are all divisible by 3, and they all have an x. So what's left? 2x squared minus 9x minus 5. Okay. Well, 2 and 5 are both prime, so we don't have a lot of choices for how to split these up. It's either going to be 5 and 1 or 1 and 5. And to get a difference of 9, right, if we, this is a little bit confusing to have them both there at the same time. If I put the 5 and the 1 like that, then 5 minus 2 is 3. That's not what we want. So I put the 1 here and the 5 here. 10 minus 1 is 9. Now we need the 9 negative, so that means the 10 has to be negative, and then the 1 will be positive. And there we go. All right. Next we have a couple solution by factoring problems. Okay, problem 10. We've got 7x squared equal to 2x. So anytime you've got a power of x higher than 1, right? Anything 2 or bigger, push everything over to the same side. Subtract 2x on both sides. Those cancel out. Over here, 7x squared minus 2x equals 0. Now you can factor this. Pull out the x. You're left with 7x minus 2. Split it in 2 pieces. X could be 0. 7x minus 2 could be 0. Get the x by itself. X equals 2 over 7. If you like decimals, that's fine. What is that going to be? 2, 8, 5, 7, something like that. The 7s have this weird repeating period. But anyway, just so long as you write it all down, I'm pretty understanding about that. All right, the key here, push everything to one side, factor out the common factor, split it into 2 pieces. Problem 11. 9x squared plus 20x minus 21 equals 0. All right, well this one's a little bit tricky because 9 and 21, neither one of them is prime, right? This could be 1 times 9 or 3 times 3. This could be 1 times 21 or 3 times 7. So we want to try to set this up so that we get a difference of 20. I'll try the 3 times 3 first. And let's see what we get. 3 times 7, so there's 21 minus 9. That's going to give us 12. That's not going to work. What if I do 7 and 3? It's the same, 21 and 9. Okay. And what if I put the 1 and the 21 here? That's going to be 63. That's way too big. All right, so it's not going to be 3 times 3. Let's try the 9x times the 1x. I'm not going to put the 7 here because that's going to be 63. Let's put the 7 here and the 3 here. There's 27 minus 7. That gives us 20. So it's a positive 20, so we want the 27 positive and the 7 negative. And there we go. Now don't forget we're solving an equation, so we're not quite done yet. All right? Once we get it factored, we still need to set these equal to 0. So x could be negative 3, or x could be 7 over 9, and that's 0.7 repeating. If you like decimals, just put a bar over the 7, right? Like that. Okay. That's problem 11. Now problem 12 is pretty challenging. That's why it's worth more points, and there's quite a bit of work involved in getting this into standard form. So let's take a look at how this one works. Okay, so number 12, x plus 5 squared equals 2x minus 3 times 3x plus 1 plus 4x. All right, so we want to expand everything and then collect our like terms and push everything over to one side. So expand this. Remember, you don't necessarily have to write it as x plus 5 times x plus 5, but I do that to remind everybody that you have to distribute x squared plus 5x plus 5x plus 25. Okay? Don't forget that you're going to get that middle term in there. So this is going to be x squared plus 10x plus 25. All right, over here, let's see, 6x squared plus 2x minus 9x minus 3. So this will be negative 7x plus 4x, so negative 3x minus 3. Okay, all right, so let's move everything. I'm going to move everything over to this side. I find it a lot easier if I keep that leading coefficient positive. So minus, minus, minus. Okay, so this all cancels out. We're left with 0. Over here, right, 6x squared minus 1x squared, 5x squared. This will be negative 13x and minus 28. Okay, so now we need to factor 5x squared minus 13x minus 28. Now the 5 is prime, so that's helpful. It can only split up as 5 times 1. Now the 28 is 1 times 28, 2 times 14, or 4 times 7. So let's see, if I put the 7 here and the 4 here, that'll be 35 minus 4 is 31. That's no good. So let's switch them, 7 and 4. 20 minus 7 is 13. Good. That's what we want. Now we need a negative 13, so the 20 has to be negative. 7 has to be positive. And again, this is an equation, so we're not quite done yet. We need to set each piece equal to 0. And so we get x could be 4, or x could be negative 7 over 5. This is a nice terminating decimal. If you want to express it as a decimal, that'll be negative 1.4. Okay. So that's problem 12. We just got a few more problems left on the rules of exponents. And like I said, you've got those formulas on the last page of the midterm. So you don't have to memorize those. So let me get this erased and then we'll look at those exponent problems. And you can get a drink of water too. Okay. So, problem 13 is all about rational exponents. It's pretty straightforward. We've got the cube root of x to the 5th, y to the 7th. And if we write this as exponents, right, it's the power over the root. Let's see, how do I write that on the formula sheet? I use m and n. So the nth root, right, the root ends up in the denominator of the exponent. And so this will be x to the 5/3, y to the 7/3. And that's all I'm looking for. Problem 14 is the opposite. We start with y to the 7/9. And right, the root is in the denominator, so it's the 9th root of y to the 7th power. If you like to put the power around the root like that, that's also correct. Either one is fine. Okay. Problem 15. Now this is where we get to use these rules of exponents a little bit more. 4y over x to the minus 3y squared, all raised to the negative 2 power, and then multiplied by 2x squared y. Okay. So, I like to simplify inside the parentheses first. So this y cancels out one of these y's and leaves us with y on the bottom. This x to the minus 3, I'm going to move that up to the top and call it x to the positive 3rd power. And then I'm going to flip this over. Y over 4x to the 3rd, all squared. Now we don't have any negative exponents that we have to worry about. So this is y squared over 16x to the 6th. And then this will get multiplied by 2x squared y. If you want to make that over 1, that works. You know, it can be helpful. Let's see. X squared cancels out 2 of these, leaves us with x to the 4th. 2 goes into 16 8 times. Notice when I work with the exponents, I subtracted, but when I worked with the coefficients, I divided. Okay, that's because they behave differently because they're different things. Okay, let's see here. This y will get multiplied by that y squared, give us y to the 3rd power. These get canceled out on the bottom. We're left with 8 x to the 4th, and that's it. Okay, so not too bad, but yeah, there's a few steps you have to go through to get to the answer in that one. Let's see if we've got enough room here to do problem 16. If not, I'll just erase that, push it out of the way. Okay, so 8 AB to the 5th, and then 3A over A squared B to the minus 7th to the negative 3rd power. Now, this is actually very similar to problem 15, right? Because this A cancels out one of these, and then I'll move that B to the 7th up to the numerator, make it B to the positive 7th. And then next, I'm going to flip that over before I try to raise it to that power. I'm going to flip that fraction over and get rid of the negative exponent there. So we got 8 AB to the 5th, and then A over 3B to the 7th to the positive 3rd power. So that's A to the 3rd, not 9, 27. B to the 21st. And again, I almost made that mistake. Notice here, I multiplied 7 times 3 to get 21. But here I did 3 to the 3rd power, 3 times 3 times 3, to get that 27. And again, that's because they behave differently, because they play different roles. All right, let's see here. The 8 and the 27 don't have any common factors. We're not going to do any canceling. The B to the 5th will cancel out 5 of these, leave us with B to the 16th. So it looks like on top, we're going to get 8, A to the 4th, and on the bottom, 27, B to the 16th, and there we go. Okay? So, with these problems, they can get kind of involved. There are lots of places to make mistakes. Do the best you can. Firm believer in partial credit, right? So if you have, one small error in here, that's fine. I'll just take off 1 point. These problems are worth 4 points. So be careful when you're working through these and do the best you can. As always, if you have any questions on this, please let me know. Thank you.